Hello, today we're just going to go over the ideal gas law. So we've just gone over all the different properties of gases and how they're related to each other. And if you take all of those equations that we got from looking at whether it was a direct or an inverse relationship and combine them, you get the ideal gas law. All right, so this is a pretty short video. We're just going to go over one example, and I'm going to go over what the equation is and what all variables stand for and what units your numbers need to be in. All right, so the ideal gas law is just PV equals nRT, okay? And so those are all variables that we've looked at except for R. R is a constant that I'll talk about in just a second. So in the equation, P stands for pressure, and that can either be in atmospheres, which is what I usually give you, or it could also be in millimeters of mercury, which is the same as torr. So those two units would be the same. Those are all options for pressure. For volume, which is V, it's always going to be in liters. So if you're given milliliters, you'll need to convert to liters in order to get to a value that you could use to put in the equation. N is going to be moles. Sometimes your problem will give you the quantity of the gas in grams, and you'll need to use the molar mass to get to moles. So N has to be in moles for this equation. R is the gas constant, which I will always give you. You do not need to memorize the gas constant. And the gas constant is either 0.0821 if your pressure is in atmospheres, or if your pressure is in millimeters of mercury or torr, which are the same thing, then the value would be 62.4. Right? So because we have this similarity between different kinds of gases, there's a constant that relates all of these properties to each other as long as we're talking about the number of particles, which is why N has to be in moles and not grams. All right, and then T is the temperature, and like I said in the previous video, it always needs to be in Kelvin, not in Celsius, not in Fahrenheit. It has to be in Kelvin. Right. So now let's look at an example. So if we have dinitrogen oxide, which is N2O, which is used in dentistry, it's laughing gas if you've ever had like a cavity filled. Sometimes they'll use that. So what is the pressure in atmospheres if we have 0.350 moles of N2O? We're at 22 degrees Celsius, and we have a 5-liter container. Okay, so the first thing we want to do is define each of the variables, and then you could just easily plug them into your equation. So pressure is what we're looking for, and we want it in atmospheres when we're done calculating, so that's good to keep in mind. The volume is 5, all right, and it's already in liters, so we don't need to do anything to it. It gave us the number of particles in moles, all right, so we can just use that number. That's 0.350. R, we're going to use the 0.0821 because it's asking for the pressure in atmospheres. So we'll want to use the one that has atmospheres in the units. Okay, and then the temperature was given to us in degrees Celsius as 22. Remember, we need to add 273 to get it into Kelvin. Okay, so now if this is our equation, we just need to plug the numbers in. If you're a little rusty with algebra, this might take a little more practice, but there are no new math skills here. All right, so we're going to plug in P. We'll just leave as P because we don't know what it is. If it makes you feel better to use X and solve for X, you can do that. It's the same process. It's just a different letter. Just keep in mind that you need to remember what it is you're calculating, so you can put the units at the end. The volume is 5. N is 0.350. We chose the 0.0821 as the gas constant, and 295 was the temperature we calculated in Kelvin. So first we'll multiply everything on the right side, and then divide both sides by the 5 so that we can get P by itself. And so our pressure for this gas is going to be 1.70 atmospheres. Right? So that's all that's to it. Now that we've looked at all of the different relationships, putting them all together is actually relatively straightforward and just a little bit of algebra. So we'll do a little practice with these in class, and hopefully you'll become experts with using the ideal gas law.